AI in electronics and communication. Today's sessions are highly insignificant as they focus on advanced and impactable domains of artificial intelligence. It is my privilege to introduce our distinguished resource person for session 1, Dr. K. Hema Sankari. Dr. Hema Sankari is currently serving as Associate Professor in the Department of Computer Application at Women's Christian College, Chennai. She also serves as the Innovation Activity Coordinator of the Institution Innovation Council, contributing actively to foster research and innovation among students and faculty. With 19 years of rich teaching experience, she has handled a wide spectrum of subjects including cloud computing, digital logic, multimedia systems, software engineering, and operating systems. Her broad expertise reflects her strong interdisciplinary foundations. Her research interests span across artificial intelligence, blockchain, Internet of Things, and software engineering domains that strongly connect with today's session on AI in robotics, automation systems, and industrial automation. Dr. Hemasangari has authored 4 books with ISBN, including Introduction to Python Programming and Concepts of Blockchain, and has contributed chapters to Springer publications. She has chaired conferences, served as a resource person in numerous workshops and seminars, and has consistently contributed to academic excellence. She is the recipient of prestigious Best Young Researchers National Award from IRDB in 2017. She has also won the Best Paper Award at an international multidisciplinary conference for her research on concealed weapon detection using millimeter wave and IR fusion imaging. She has published several research articles in peer-reviewed international journals, including Elsevier, Scopus Indexed, and Springer publication, and has presented numerous research papers during her postdoctoral work. We are indeed honored to have such a dynamic academician and researcher with us today. I now invite Dr. Hema Sankari to deliver her expert talk on AI in robotics, autonomous systems, and industrial automation. Ma'am?
Thank you, Dr. Prema. Good afternoon and warm greetings to everyone here. So I was very much happy to be the part of this faculty development program on interdisciplinary applications, AI in electronics and communication. And first and foremost, I thank the organizers for organizing. I'm being part of the participant for all the 4 days, and it was amazing. And the organizers have done it properly. And I should thank especially Dr. Ramid, who's the secretary of AMIE Association, for giving me this opportunity. And I'm very much glad to share few of my knowledge about AI and robotics and autonomous systems and industrial automation. Without any further delay, let me share my screen and we are going to the session. Am I audible? You can able to see the screen?
Yeah, ma'am. Screen is visible.
Okay.
But not in full screen mode, ma'am.
Not in full screen mode?
Yeah, ma'am.
One second. Window.
Okay. Yeah, ma'am. Now it is in full screen.
Yeah, thank you.
Thank you.
So why we are going to talk about AI in robotics? Because nowadays artificial intelligence is revolutionizing robotics by enabling machines to perceive, learn, decide, act, and autonomously. For example, traditional robots follow just instructions what the programmer gave, but AI-powered robots can now adapt to dynamic environments. It improve through experience and collaborate safely with humans. So let me talk about few examples, uh, especially when talking about the manufacturing tradition. A robot will repeat the same welding task only. Okay. But if it is AI influenced or AI robot, it detects defects and edges, and welding automatically will be done. And for example, if you take in the cleaning traditional, so if you follow a fixed path, okay, it just follows a fixed path what has been programmed. But in the influence of AI, it is not the same. It learns the room layout and cleans more efficiently. And talking about the healthcare tradition, so here the robot moves exactly as programmed. But AI robot it assists surgeons by analyzing data and improving accuracy. So, and talking about even the warehouses traditions, robot stops if an obstacle appears, but AI robot finds a new path around obstacle, especially we can say in the self-driving vehicles. And I always think that more than what we put it in the slide, like picture talks more. So here, AI robotic solution nowadays, like it is a recent news. It has been launched in Gurugram. So it is known as a Sky Hair. So we are India's first end-to-end autonomous delivery system, where AI-powered drone, UAVs for aerial transport, and AI ground robots for doorstep deliveries. So it is full and fully like automated. So AI-based navigation, routing, obstacle avoidance, and monitoring. And it is designed by hyperlocal and last mile logistics. And what are the benefits on it? It is faster delivery, reduced traffic, lower emission, and it is scalable logistics. So like, and it has been unveiled at the AI Impact Summit. Okay, so this is how like AI has been influenced. So when talking about the historical evolution of robotics, so it has been begin with a simple mechanized tool. Okay, so like in the mid of 20th century. So the introduction of the first industrial robot unit marked the beginning of an automated manufacturing. But here, like over the decades, now we are coming to the 21st century, the integration of AI in robotics had shifted robotics from a rigid automation to an intelligent, self-optimizing system capable of interacting dynamically with the environment. So this is very important here. And like everybody would have known about what are the core domains in artificial intelligence. The main concept around this session is we are just going to see how AI had influences, what are the integration we had done in the robot, so that how far it is using. So the core domain we know it is machine learning, deep learning, computer vision, natural language processing, and reinforcement learning. Okay, so like the foundation of AI here. So again, I say the diagrammatic representation. So it's everything. We have to know mathematics, philosophy, linguistics, psychology, economics, cognitive science, biology, computer science, and engineering. So now the exact of we say like interdisciplinary. So AI works in every field here right now. And what is the architecture of intelligence system? How it works? First and foremost, we have the sensing, the perception. Okay. The second one is data pre-processing. Third one is feature extraction. Fourth is knowledge representation. And fifth is reasoning and inference. Sixth is planning and decision making. Seventh, learning. Eighth, control. Ninth, acting or execution. And finally, we have the feedback loop. Okay. So till now I'm audible. Is it clear? Anyone from the participants? Yes, thank you. Thank you, Mr. Prakash Sharma. Thank you. Yeah. Next is when talking about this architecture, so how this machine learning and robotic control, how it works. So machine learning allow the robots to move beyond rigid fixed programming, and robots learn from sensor data, past experience, and environmental feedback. So let me say a small example. Before, like a wildlife photographer has to go around physically, he have to wait to capture anything. Like for example, we are in a project of like capturing a number of elephants in that particular forest, or lion or tiger, whatever animals. Okay, so before now, photographer has to wait, take account and everything. Now you can do everything with the machine, but we have to teach the machine. So for example, I'm going to place the image of an elephant. Okay, and I teach. Okay, I make it learn. The machine has to learn it, and not only one particular position of the elephant, in all the views, 3D dimension, everything, because sometimes a trunk or whatever it may be, but it has to capture, it has to record as elephant one, and the features of a tiger, the image and everything, and then tiger one. So, and they can just leave and move away. Later, if they come back and they see, they can see how many animals has been recorded. So this is how it works. So the learning improves accuracy, efficiency, and overall performance. And the supervised learning helps robots learn correct actions from the examples. And we say the reinforcement learning enables robots to optimize movement through trial and error. And these techniques enhances stability and adaptability in dynamic environments. And integrated machine learning with control system enables smoother motion, smarter and decision making. Now, deep learning and neural network models. So, as I said, like deep learning uses multi-layered artificial neural network to handle complex and high-dimensional data. So these networks allow robots to process large amount of sensory and visual information efficiently. That's what I said, whatever we put it as an image. And CNN, okay, it enables robots to recognize object and interpret visual sense. And CNNs are widely used for quality inspection and detect defection in manufacturing lines. And RNN, okay, RNN, recurrent neural network, help robots process sequential and time-dependent data. So transformer-based architecture, it supports advanced temporal data analysis and decision making. And deep learning improves perception accuracy in robotic system. And also it enhances understanding and enables a real-time adaptability, okay, in this dynamic environment. So not only static, only not one particular image is going to work it out. So it has to learn. Now, this is about the computer vision and environmental perception. See, for example, as I said, an example for the forest, the image of an elephant or tiger, whatever it may be. So the computer vision and robotics, it has an image segmentation. The object will be detected, depth estimation, and then the application. So this is how it works. The first will be the image segmentation. Next, the object detected, depth estimation, okay, and then the application. Okay, so not only how AI in robotics we saw, we are just moving on to the understanding the autonomous system. So autonomous system are intelligent entities capable of operating independently without constant human supervision. That's what I said. The photographer should not or has to wait for the whole day and night. You don't know, he can leave and come back later and collect the details. So that's what here the integrating sensing technologies, data processing algorithms, and control mechanism does all the work where the human is not there. And these components allow system to make decision and execute actions autonomously. So autonomy requires environmental awareness through continuous sensing and perception. And autonomous systems exhibit goal-oriented behavior to achieve specific objectives. They can adapt to changing and dynamic conditions in real time. So most of those autonomous systems are widely used in transportation, defense, logistic, and industrial automation. So what is about the perception, planning, and control and autonomy. So autonomous system hierarchy, first and foremost, is a control. So it executes movements through actuators, and it has to be perception. Okay, gathers environmental data through sensors, and then the planning, analyze data to generate a action strategy. So executes movement through actuator. So any wild animal is fast, so it has to sense the movement. It gathers environmental data through the sensors, okay, and then analyze data to generate action strategies. This is an example about how it works, and the diagrammatic representation you can see. Okay. Now, what is the difference between autonomous vehicle and intelligent mobility? So we say like first and foremost, the characteristic of focus. Okay, in autonomous vehicles, AVs, self-driving cars. So, but the intelligent mobility will be broader transportation systems. Okay, and then key technologies, AI algorithms, sensors, real-time data. And what is this V2V? So we say as a vehicle to vehicle, or V2I, it is vehicle to infrastructure communication. So smart traffic management. So what are the benefits actually? It reduces the human errors, autonomous vehicle, it reduces human error and increase accessibility. So here, intelligent mobility, it reduces the consumption, improve fuel efficiency. And what are the challenges? So safety validations in autonomous vehicles, safety validations, regulatory approval. Okay. But in the intelligent mobility, you have an infrastructure, ethical readiness. Okay. And this is about we can able to address about how intelligent mobility is going ahead. Okay. And now, autonomous aerial systems and drones. And the first is a traffic flow optimization. Okay, AI algorithms. So you can see in a car what not has been done. So autonomous vehicle navigation, traffic flow optimization, the algorithms, safety improvements, sensor fusions, mapping, and then the precise localization. Okay. So in my session here, we started with what is AI in robotics, okay, and then we move on with what is autonomous system, how it works, and we are now introduction to the industrial automation. So what is this industrial automation? Everyone are familiar with nowadays the Industry 4.0. So here, the factors enhancing the industrial automation. So the first is artificial intelligence, the control system, robotics, information technology. So how the industrial automation involves the use of control system, robotics, information technology in manufacturing. It is applied to monitor, control, and manage production process efficiently. And early industrial automation focused mainly on a repetitive mechanical task. So that is the difference here. So doing on the regular basis of how the program has been instructed to it. But now modern automation systems, which is integrated with the artificial intelligence for intelligent decision making. For example, like if there is any block in between, automatically the traffic before just an automation, it just stops. But here in the integrated artificial intelligence for intelligent decision making, it find out another way. So automation significantly enhances productivity and operational efficiency. It reduces human errors and improves workplace safety. And automation ensures consistent quality standards across production lines. Okay. So the emergence of industrial automation. So the industrial automation represents the revolution characterized by the integration of cyber physical systems, IoT, and we are familiar with how this IoT is all about. They say that more than billion of physical items, it may be a pen, it may be a whatever, like day-to-day physical objects what we use, has been connected with IoT. And in the future, they say they are going to be millions of objects are connected. A camera become a smart pen can be used as a camera. So everything has been integrated with AI. So cloud computing and artificial intelligence and smart factories. So we know always the word smart comes. Okay, a watch become a smart watch, not only showing time, but it also now read the heartbeat. Okay, a number of steps. How it is possible because everything has been connected with the IoT. So user interconnected machines that communicate and optimize operations autonomously. And real-time data analytics enables predictive insights and adaptive manufacturing process. So how we are building the future of manufacturing is going to be. So how a smart factory is going to be. So cyber physical systems. So integration of physical and digital systems. That's what I said. The physical device, either it is a watch or pen, whatever it may be, a physical device that has been connected to the digital system. So IoT, network of devices collecting and exchanging data. And cloud computing is scalable computing resource as accessible via the internet. And definitely the AI, intelligent system analyzing the data and making decisions. So this is about how the building the future of manufacturing. AI driven smart manufacturing. So here, again, the diagrammatic representation, how the operational data analysis are taken place. The first one is we are going to have an improved scheduling, okay, and then optimize workflows, okay. It reduce the material waste, okay, because the machines are going to do correctly and detects anomalies and then forecast the demand, and then it becomes the enhanced factory efficiency. So AI driven manufacturing systems analyze operation data, they optimize scheduling, workflows, and the resource usage, and the intelligent algorithms detect anomalies, okay, anomalies and forecast demand, and AI improves production, planning and reduce waste, and factories achieve higher efficiency and better responsive to market changes. Okay, now what is this predictive maintenance and fault reduction? So the benefits of predictive maintenance, what is it actually? So this diagrammatic representation shows that it is till now it's clear. Anyone from the participants? Were you all with me? Yes. I didn't get any response even in the chat. Okay, thank you. Yes. Now this predictive maintenance and fault reduction, we talk about the extended equipment lifespan. So it enhances the machine longevity and operational efficiency. Actually, it is important to have the machine longevity because we are spending a lot of money. So that is very much important. So the lifespan of the machine has to be considered and reduced downtime. So minimize unexpected machine stoppages and disruption. So this is all the challenges in traditional company manufacturing factories, but now it has been reduced and lower maintenance costs. So it optimizes maintenance schedules and resource allocation. So now, how this collaborative robotics in industry? Like you have a cobot benefits, that's what we say, and the collaborative robotics. It enhances the productivity, so it increases efficiency and output in manufacturing. It increased flexibility. So you can see here. So cobots adapt to the changing production needs and environment. And you can see the improved safety. That is, cobots minimize workplace accident and injuries. Before all these are the output or the efficiency or the need of the changing productions and the accidents and injuries are more, but now they are saying these and all has been reduced and safety is improved, flexibility has been increased and enhancing productivity. So collaborative robots are designed to work safely alongside human workers. They are equipped with advanced sensors for real-time perception. So AI-based motion planning allows cobots to adapt to human movements, and cobots adjust to changing environmental conditions during operation, and they improve productivity, safety, and flexibility in manufacturing environments. Okay. So now next we move on to the safety and reliability in autonomous system. Okay. Now the first and foremost is handling uncertainty. Okay. So handling uncertainty, autonomous system operate in dynamic and unpredictable environments. AI-driven adaptation, it enables system to respond effectively to changing conditions, incomplete data, and unexpected scenarios. So most of the time, handling uncertainty is for the human, it's quite difficult. But wherever it says in the autonomous system, it operates in a dynamic and unpredictable environment and preventing failures. So, fail safes are crucial here, and fail safe mechanism are essential to avoid system breakdowns. Multiple sensors and backup control strategies ensure continuous operation even when individual components fail. And then maintaining stability. So, it is very important. So, robust perception and decision making are very much needed here. It reliable in sensing and control algorithms. It help autonomous system maintain consistent and predictable behavior. And then ensuring trust. So testing, validation, and regulatory compliances. Okay, behavior and safety. So like human robot collaboration. Like a human robot collaboration. So the first one is human strength. So we are not saying that only robots are going to do all the work, but we can say the humans contribute creativity, adaptability, and complex decision making uh, abilities. Okay, the Excel actually talks about handling unstructured tasks, problem solving, and we can also say responding to unexpected situations. So human strengths are there. Okay, but see, anything what we are going to give instructions. So improvisation especially come from the human mind. Certainty. Okay. And I got a question in the chat talking. Let me check. What are the types of uncertainty in real world? Okay. We can say like model uncertainty. If you want the term like we say like epistemic uncertainty, some not enough for the similar examples or when it was for more diverse data. And then the second is like we can say a data uncertainty. So, for example, a self-driving car camera image blood by for example, in a rain or a fog. So that may be. And the next may be the distributional uncertainty. So out of distribution, we can even say as OOD. Okay. So financial fraud reductions we can come across there, and model misspecification. So sometimes wrong assumptions in probabilistic models. Okay, and of course we have like parameter uncertainty. So I hope I answered the question. Yes. Okay. Let me continue with the human and robot. Thank you for asking questions because it make the session interactive. Thank you. The next is robot strength, because now we are going to talk about human and robot collaboration. So human strengths are creativity, adaptability, and complex decision-making abilities. Robot strength is robot provide high precision, physical strength, and consistent performance. They perform a repetitive, high accuracy task efficiency without any tired, and they are very much in speed and reliability. And how these both the collaborative intelligence that plays a very important part here at the human strength, there comes the robot strength, and here come the collaborative intelligence. So enhanced productivity, safety, and flexibility. Sorry. Okay. So by combining human intuition with robotic precision, collaborative intelligence enhances productivity, safety, and operational flexibility. And AI enables robots to understand human actions and work seamlessly alongside people, creating efficient and intelligent work environments. Now, what may be the future trends in AI robotics? So, you can have ethical AI, safety, transparency, and social acceptance. Nowadays, as technology develops, we know even the hackers or unwanted people, they do unwanted actions, that is again going to have a wrong impact on the technology. But ethical AI, the future robotic system, will prioritize safety, transparency, and social acceptance. And this acceptance, it's because the ethical AI ensures responsible decision making, fairness, and trust in human robot interaction. Multi-skilled robots. Robots are involving in general purpose adaptable system capable of performing multiple tasks. So this flexibility increase efficiency across the industries. And human aware robotics. So AI enable robots to understand human intent, behavior, and context. So that is very much important because this improves collaboration, safety, and natural interaction between the human and robots. Next, edge AI. So this edge AI allow robots to for the real-time intelligence, okay, data locally in real-time with low latency. This reduces dependence on cloud system and enables faster, more reliable decision making. Swarm robotics. So talks about focus on coordinated group of robots working together to complete. So it talks about inspired by collective intelligence in nature. And also we can say explainable AI, everything is raised transparency and accountability. So this is very important. Okay, the future trends. Moving on towards fully autonomous smart factories. So now moving from small objects from smart walls, smart home, smart AC, whatever thing. Now we are moving on to the fully autonomous smart factories. So high human intervention. So traditional manufacturing system rely heavily on human involvement for monitoring, decision making, and process control, which can limit efficiency and scalability. Whereas the integration of AI, IoT, and robotics, the transition of a smart factory occurs to the integration of AI, IoT, and advanced robotics. And these technologies enable real time data collections, intelligent analysis, and autonomous coordination. And we can say the efficient, resilient, and intelligent manufacturing, fully autonomous smart factories operate with minimal human intervention. It's reliable. Okay, so that is very much important. But as I say, we are also having research challenges and limitations, handling real world uncertainty. So autonomous and intelligent system must operate in unpredictable environment with a noisy sensor data and incomplete informations that making reliable perception and decision making challenges. I'm just focusing on this research challenges because as it is a part of FDP where faculties are involved, research students are involved. You can find out the gap, what are the challenges, and you can work it on it. So that is my intention. I'm just showing this research challenges and limitations. Data dependency and scalability. So AI-driven system require large volumes of high-quality training data. So collecting, labeling, and validating such data is costly and often it is impractical. And then safety and explainability. So many AI model functions are black boxes, making it difficult to explain. So we can give a input, we can get the output. So what is the internal process? And excess computation and resource constraint. So real-time intelligence demands high computational power, especially for edge-based systems. So ethical, legal, and finally the regulatory barriers. So standardized regulation, ethical concerns, cyber security risk. That's what I say. Like how far the technical technology are happening. Again, we find people who are doing some hacking and other things. So I'm sorry. Anyone in the yes. So handling uncertainty, data dependency, real-time performance, safety and reliability, and then ethical consideration. We say this is as a research challenge and limitations. And finally, I can conclude saying that AI has emerged as a transforming force in robotics, autonomous system, and industrial automation. And it is from a rule-based machine to intelligent, safety, adaptive system. And we can say that AI-powered robotics and smart factories enhance efficiency, precision, flexibility, and sustainability. So now, like at the same time, human-robot collaboration is redefining work environment by combining, as I said, in the human creativity, the robotic precision. And despite challenges, overall, we can say it is a critical foundation for the future of intelligent industries and autonomous technology. I hope people can follow me what I have. And this is all about my presentation today. And I'm open forum to the any question sessions. If you have any queries. Along with my presentation, I even check it out the chat, and I hope I answered.
Ma'am, no queries available in chat, ma'am. Thank you very much, ma'am.
Yeah, thank you so much. And
thank you, audience. From any query from audience side or participants, any query?
Okay, now moving on to the fifth slide of the annual.
6 खुल गया अब आ गया ओवन का नंबर आ गया.
So on behalf of the organizing committee, I extend our heartfelt gratitude to Dr. Hema Sankari for her highly insightful and enriching section. Your presentation has given us a deeper understanding of how artificial intelligence is transforming robotics and industrial automation. We sincerely thank you for sharing your valuable time, expertise, and research insights with us. I also thank all the participants for your active listening and engagement, which made this session interactive and meaningful. Thank you once again. We look forward to future collaborations.
Thank you, ma'am. Yeah, thank you so much, Dr. Prema, for the introduction, the coordination. And I have to thank the AMIE Association for giving me this opportunity. And hope we continue with a lot of learnings like this. Thank you so much. Thank you.
Thank you, ma'am. Thank you. Santhya Arora. Dr. Santhya Arora. Ma'am, Sandhya Arora, ma'am. Please respond me.
Yes.
Yes. Shall we start the session, ma'am?
Are
you ready?
Yes, I am. I put my stylus on the charge.
Oh.
Just give me 2 minutes. Just
no
give me
problem,
I'll
ma'am.
start.
We will wait for 5 or 10 minutes. Okay, ma'am. No
Okay,
problem.
okay.
Okay,
Sure,
no,
sure,
okay, ma'am.
sure.
Now the best channel.
No, madam.
Yeah. Are you ready, ma'am?
Yes, yes. Should we start?
Okay, ma'am. Okay.
Yeah.
Okay, good afternoon once again. It is a great honor to introduce our distinguished research person for session 2, Dr. Sandhya Arora. Dr. Sandhya Arora is serving as professor in the Department of Computer Science and Engineering at Communist College of Engineering for Women, Pune. She completed her PhD in Computer Science and Engineering from Jadavpur University, Kolkata, and holds an M.Tech from Pansandali Vidyapith and a BE from University of Rajasthan. With more than 20 years of teaching and research experience, she has made remarkable contributions to academia and research. She is a life member of ISTE, CSA, and ACM and has an impressive record of over 90 research publications in reputed international journals and conferences, including Springer and IEEE Open Access. Dr. Arora has published 7 patents and has 3 granted patents to her credit, a testament to her strong research and innovation capabilities. She is the recipient of several prestigious awards, including Devang Mehta National Education Award for Best Professor in Computer Engineering, Professor Indra Bakri 50 Women Leadership Award, 100 Most Dedicated Professor Award by the World Education Congress. She has authored 10 books, including R Programming for Beginners and Data Science Analytics with Python, and has edited multiple books such as Artificial Intelligence and Machine Learning for Real World Application under CRC Press, Taylor, and Francis. Seegers also served as session chairs, technical committee member, and resource person for numerous AICTE, ATAL, DST, and university-sponsored FDPs and conferences. We are truly privileged to have such a distinguished academic leader with us today. I now invite Dr. Sandhya Arora to deliver her expert session on AI in signal processing, image, and video analytics. Ma'am?
Yes. Thank you, madam.
Thank you, ma'am.
I'm sharing my screen.
Yeah, ma'am. Sure.
Yeah. I hope this is visible.
Yeah, ma'am. Not in full screen mode, ma'am.
Yeah. It's not in full screen.
Press F5.
Yes.
Ma'am, not possible means you can continue with this one. No problem.
No, but then I think I should slide share. Is this okay now?
Wait. Okay, ma'am. Okay, then.
Okay.
Okay, thank you, ma'am.
Yeah, thank you. Yeah, okay. So just wait a minute, I'll lock the door.
Okay, ma'am.
Yeah, okay. So what I'll going to cover is I'll cover some application or something related to how AI is used in signal processing, image, and video analytics. So if you see three different topics coming here related to AI, signal processing, image, and video analytics. There are several models for all these doing all these signal processing or image or video analytics, but we'll talk about basically a single model which is actually very helpful in case of image and video analytics. If you talk about signal processing basically it focus on manipulating analog and digital signals like audio or sensor data. You could remove noise, you could compress, and you could classify patterns using those signals. Image analytics means using some AI models or techniques for tasks related to image classification, maybe image restoration, maybe image enhancement, or finding out some patterns for medical image analysis or autonomous system. You could apply those things to various applications. And talking about the video analytics it is basically related with the image analysis only, because sequence of image video consists of sequence of frames only. So video analytics extend the image methods only just to add some temporal sequences. So maybe motion tracking, anomaly detection, or some kind of behavior analytics. All the applications which plays a major role in surveillance and intelligent traffic system, all these are part of video analytics. So AI in signal processing and image video analytics are the applications of AI techniques, particularly machine learning and deep learning techniques. So if you talk about all these broad areas, signal processing, image or video analysis, particularly deep learning methods are very helpful to analyze, enhance, or some extracting some meaningful information from these signals, images, and video data. So we are going to talk about CNN today, and I'll try to tell you about the CNN, how it is used for image classification, and then we'll see how you can build your basic CNN model in Python. So the basic foundation, AI in signal processing, image, video analytics are deeply connected to the neural networks, especially convolution neural networks. Convolution neural network is a deep learning model which excel in capturing the spatial hierarchies of the data which is for image data and for video analytics. These deep learning models are very helpful. They gives you result wise, they are capable of handling complex data, and they gives you result also accuracy wise. Performance is very good of these neural network model. Obviously there are certain deep learning models, but then all are not applicable to all kinds of applications, because each deep learning model has some specific technical details in it, so which fits for a few applications. Like for example, CNN is best for doing image classification. CNN has given its CNN basically has given, if you compare CNN with other neural network models, CNN gives you it outperforms other NN models. So let's see what CNN is based on neural network. So just let me cover few things about the neural network, because the basic concept of CNN is based on neurons only. So neural network is nothing but network of all neurons. So this neural network consists of a network where neurons are densely connected. Every neuron is connected with every other neuron. So this neural network, actually you can treat this neural network as a computer system or a computational model which is inspired by the structure and behavior of our biological neurons. Our whole body is whole body runs or behaves with the help of neurons only. We have so many, I think we have over 100 billions of neurons in our body. They are so densely and deeply connected with each other that our human body behaves properly because of those neurons only. In brain only, I think we have over 10 billion neurons only in the brain. So if you define neural networks are the computer system that is inspired by the human brain, and those neurons learns the pattern from the data, and they are so densely connected and organized in layers, and they learn from the experience. And the computation which happens in neural networks, that is a massive parallel computation, extremely efficient computation happens. So if you see this neural network model, biological neural and artificial neural network, we have a analogy of each part of the biological neuron with artificial neural network. Like for example, this is SOM, and which is considered as a node in case of, if you want to simulate a neuron, you have an analogy in artificial neural network. Like biological neuron has this nucleus or SOM, which is called as node in case of artificial neural network, and which the task of that SOM is to process the information. And this is not only the single neuron, you have multiple neurons connected with each other. So how they are connected, how they pass on the signal, they are all like for example, dendrites. Biological neuron had these dendrites, which dendrites are considered as the input in case of artificial neural network, which input means which receives signal from the other neurons. These neurons are all interconnected with each other. They don't work independently. And what is synapse? Synapse is this, where the weight interconnection happens. Some information from this neuron, some information from this neuron, that both information gets connected with each other, and that happens at the point of connection, which is called in case of artificial neural network, this is called as the weights or the interconnections. And axon is the which is responsible for transmitting the information to other neuron, which is considered as the output of the neuron. So for these four biological neuron, we have a similar analogy in artificial neural network also. You have a node which takes some input and it produces the output based on weighted interconnections. So if you see the basic model of the artificial neuron, this basic one single neuron architecture is like this. It takes several inputs, x1, x2, x3, and so on, xn. It has a bias also, and this input is multiplied with these weights, and output is generated based on the processing which is happening here in the neuron. What processing is happening? this weight get multiplied with this input will be multiplied with this weight, bias will be added, and this output will be given as input to an activation function. Activation function will decide whether output should be given, what kind of output should be given. Now, this activation function also plays a major role. The kind of activation function you use, it changes your application. So what here is, for example, if you want that all these summation of all these inputs multiplied by the respective weight, if this wi and xi addition of all this for all neurons is greater than equal to some threshold value, my output threshold could be anything. I can take threshold as 5, 10, whatever, or 0.1, 0.5, whatever. So based on the application. So if my input is greater than that threshold value, output will be 1, otherwise output will be 0. So this is the basic model of neuron, where these weight updation, how this weight updation happens, how this is getting summed up, and how and what kind of activation function you are applying is basically the crux of neural network. Now, neural network is dense of neurons which are interconnected with them and all work parallelly. So neural network is just not a single neuron, it has a multiple neuron, and these neurons are arranged in different layers. You have input layer where you give the input, and you have hidden layers also. Hidden layers could be any number of hidden layers, and any number of neurons could be in one layer. So you give input. Now this input is connected with the all neurons of hidden layer at first level. This second will also be connected with all neurons of hidden layer second layer neurons, and that you could have 3 layers of hidden layers here. You could have 1, you could have 2, you could have multiple hidden layers and multiple neurons. Multi-layer neural network is which has multiple layers, and finally you will have an output layer. So this is the basic architecture of neural network, multi-layer neural network. You give input. Now, what do you mean by learning of these neural network? Learning of these neural network is nothing but, learning means you want to update their weight. So how learning happens is, you give some input here, and because this neural network is generally used for supervised machine learning. Supervised machine learning in the sense, you have input and output is also specified. So output is also specified. So when you give that input, output is also specified. When you give this input, initial weights are there. So according to these weights, these signals will be processed, and you will get certain output. If you get the proper output, there will be no error. But if you have some different output, so there is an error in that case, because output expected was something else and you received some other output. So that error will be back propagated to this, then back propagated to this, then back propagated to this. So back propagation means what? You want to update their weights so that when you give that input, you should get correct output. So learning of this neural network is nothing but learning of these weights only. Okay, so CNN actually this is called as dense network. Why it is called as dense network? Because each neuron is connected to every other neuron of next layer. Like this input is connected to all these 4. This also connected with all the 4. Now this is also connected with all the 4. This is also connected with all the 4 in the next layer. So this is called as dense network. Whereas if you see CNN, we are going to talk about CNN now. CNN has full form of CNN is convolution neural network. Convolution neural network. This extends the traditional neural network. Traditional neural network by incorporating a specialized convolution layers, which is very good for special data processing. So while it retains the core of NN principle like backpropagation, activation function, fully connected layers, all this is there in CNN, but then it is very good for special data processing. So you can say that the CNN is a specialized type of neural network designed primarily for the data which you can form in the form of with the data which is in grid-like structure, and image is represented always in a grid-like structure. So for image processing, CNN works very well. So this was about the normal neural network. Now, if you see the machine learning, what we talked about is we talked about this neural network. So what is the input to neural network? Input to neural network is the data. Now the data, from where data is coming? Data is coming from the images or from your application area. This could be sensor data. This could be data coming from images. This could be data coming from IoT devices. Could be anything. But then you have some data. It could be text data. It could be data, categorical data. It could be data in numeric form. It could be anything. So what you do in case of machine learning, you have input, you extract those data values from the input. That is called as extracting the feature. Now these extracted feature or the data which you extracted, for example, if you want to identify a car using machine learning, so what you are going to do is you are going to feed this classifier. This is your classifier, machine learning model. So you feed this machine learning model with the properties which differentiate maybe car with bicycle or car with some other object. What could be those features? It could be number of wheels, it could be the shape, it could be the weight, something like that. So all these things you have to extract from the images or from the input. You have to extract it, and that extracted data you have to pass to the machine learning model. Now machine learning model will train based on your data, and it will give you correct output, whether it's a car or not a car. So machine learning model deals with only with the task of training the model only. But then what deep learning does is, CNN is a deep learning model. So what deep learning does is, deep learning actually here features we manually extracted from the images. So it is our task to find out those features and extract those features. But in case of deep learning, this feature extraction task is not our task. What you do is, in case of deep learning, you give input and you train your whole deep learning model, which is responsible for feature extraction and which is responsible for classification or using whatever task we are performing. Classification karna hai, ya if or object detection or something else, image compression, whatever you want to perform. So you have to extract. Deep learning model will extract those features and it will train the model also, and it will just give you the output. That's all. So you have input, you have output. In between input to output, you just have a deep learning model, nothing else. So that is how machine learning is different than deep learning. So what is our purpose now? If you want to identify, if you want to, for example, if you want to find out whether this is a historical image or is it a car or is it something else. So what you do is you apply certain features on this image. Features could be edges or sharpness or the whiteness, whatever, or applying some filters on this image, which will help you to differentiate whether it's a monument or whether it's a car, whether it's a bus or whatever it is. So you extract those features, or you could train them, or you could train your model with the raw pixels also. Direct raw pixel, no processing is happening. You are just feeding raw pixel as it is, and you are trying to identify car, bus, or monument. You could have a feature of edge detector. You could have a feature which is shift or hog features, and you could take these features as input, and that will help you to identify what is your output. So our machine learning task is only to learn the weights of the classifier, which will differentiate these. But then when we are talking about deep learning, nothing is, features are static. In case of machine learning, features are static, which is programmer's task to give those features to machine learning model. But then in case of deep learning, these features are not static, they are dynamic, and it is not our task. This is a task of model only, deep learning model, which will extract the features also, and it will train the model also. Both tasks will be done by the deep learning models. So instead of using those handcrafted features such as edge detector or raw pixels only, we can learn some meaningful information in the form of kernels or filters in case of deep learning. So in case of deep learning, not only the classifier or the machine learning model is learning, also features are also learning. So now let's talk about, there are various deep learning models. CNN, convolution neural network, is one of them. apart from this CNN, we have a recurrent neural network also, recursive neural network also. We have some unsupervised pre-trained network also available. Now these, all of these don't work for all application. For like for example, RNN works good for where you have sequence of data, or it works better for text data. A recursive neural network also works for long shot LSTM models are there, which works for time series data very well. They work very well for time series data. So likewise, we have nowadays many new models are also coming up of deep learning. Different models are coming up. Also, we have an option of unsambling those deep learning models. Instead of working with single model, you can work with multiple models and combine the models together. So if you look at the applications of machine learning, this CNN model application areas are huge. Few are, you can use them for object recognition with images. You could use it for image classification. We could use it for sound analysis. We could use it for machine vision. In the sense, you can identify faces, fingerprints, or street signs, or you can identify individuals based on what behavioral activity. Also, you can model those self-driving cars, robotics, drones. And in case of nowadays, this chat GPT and all these are natural language applications of AI. So this AI could be used in various applications. We can build very efficiently these applications. So this is another application of machine learning. Machine learning classification, it is basically classification using CNN is basically trying to classify the pattern. For example, you must have heard about MNIST data set, which is a standard data set for digits, where different data, different people have written different ways of how could they write 1, 2, and so on. Huge data set exists which is standardized. So CNN works very well for identifying what kind, which digit is written. Like, and other application is identifying the images using CIFAR 10 data set. 10 data set is 10 object classes are there. Like few images are to identify airplane, few are for car, few are for birds, and so on. Few are for dogs, few are for cat, and so on. So we have all these are free data set available on Kaggle. So we can make use of these to identify the images. Likewise, we have other applications also. We have ImageNet data also, where different kinds of images exist. All these data set actually came out of challenges from different companies. This CNN could be used for image compression also. Image compression in the sense which reduces the storage requirement of the images, which helps you to transmit the data efficiently. So you could use CNN also for image compression. You could use CNN for the classification and localization. Localization is, for example, this is classification just to identify whether this picture has a cat or dog, whatever is a classification. Look, it could be used for localization also. Localization in the sense it locates the presence of particular object in the image. So it gives you a bounding box around the object. So this is object localization. You could use CNN for the object detection also. You could have multiple localized thing in single image, which could be multi-class also. Like this class has 2 cats or 2 dogs, something like that. So you could use CNN for object detection also, for segmentation and for semantic segmentation. This is a grass, this is an object, this is another kind of object, this is another kind of object, and so on. You could use for image denoising also. CNN could be used for image denoising. Denoising in the sense your image has some noise in it. You can see it here. This is not a clear image. You could use CNN for denoising the image, this image looks very clear. So you could use CNN to remove the noise from the image also. These are, now I'm just telling you about the application. Now how to do this itself is a whole, we could have whole session on.
Hello, am I audible?
Yes.
Actually, your voice is cracking. I don't know that my network problem issue or
Yeah,
from
sir, that
your
is
side.
your problem, sir. This side network is okay.
Okay, ma'am. That means it is my problem.
Secure
Thank you.
network. Okay.
Thank you.
And continue.
Okay, yeah, thank you. So image denoising, I'm just talking about just one slide. I'm just telling you, you could use CNN for image denoising, but then denoising, how to use CNN for denoising is itself is a whole project. Like you could see it here. This is your original image. You could see multiple noises here. And last image is this. You could see this is a clearer compared to this. This image is quite clearer. So how this is used, you could have multiple layers of convolutions with specific values, and then you could see that multiple layers. After applying that in multiple layers, you could see this is a quite clear image. Now let's talk about CNN. We are talking about so much about CNN that CNN is used for image data very effectively. So let's see about how CNN is used for image classification. So I'm taking very basic thing about CNN. I just want you to, we use CNN multiple times, but I want you people to be knowing about what is intricacy or what is happening behind the scene. You just make use of a function in Colab or in Python. We just make use of one function, but actually what is happening, you should know that. So when you talk about CNN, there are three basic components in CNN. One is convolution layer, second one is pooling layer, third one is the output or fully connected layer. So you can see it here. You have input and you have a convolution layer, you have a max pool layer. Out of this, after max pool, you could have multiple convolution and max pool layers. You could have multiple convolution and multiple max pool layers. Now, after applying that multiple times, finally you will have a output layer or fully connected layer. Now this output or fully connected layer could have multiple. One fully connected, then second fully connected, then third fully connected, and so on. And finally, output comes from the last fully connected layer. So you could have multiple of these layers, and you could have multiple of these layers will give you final output. Like here, you could give how training happens in case of CNN. You give input and you apply those multiple times and you get an output, whether the given image was of a bird or of a sunset or of a dog or of a cat or of some other object. So how training happens, you give input and you specify the output also. Now when you give input and specify the outputs, this network learns. Next time when you give this image, it will again learn. Learning means it adjusts its parameters. Once learning happens, and after this neural network has or CNN has learned properly, and when you give test image, what is our purpose? Test image should be classified properly. That is ultimately what we want. So if you see in case of nowadays, we don't use neural network actually, but then neural network is a basic foundation of CNN. CNN handles images quite well in the sense we don't have 2D images nowadays. We have 3D images, correct? So image is represented in the form of a matrix where height and width is specified and RGB channels considered as the depth. So now CNN works with 3 or 4 or multiple dimension structure very well. So if you see this, image is always represented in the form of matrix, where each value could represent, it could be intensity of red, green or blue channel, or if it is a grayscale, it could be any value between 0 to 255. If you see this colored image, so this colored image has 3 RGB. So 3 red, blue and green. Red, blue and green. The value of RGB 3 channels altogether specifies the value of this image at this pixel value. So this 3 RGB, actually this defines the depth of the image. X and Y, you can see here, this is X direction, Y direction. So you could see here the depth considers RGB values. So now the basic thing about convolution neural network is the convolution operation and what is happening in these 3 layers. Actually, we want to see that what is happening in convolution layer, what is happening in max pool layer, and what is happening in dense connection. Actually, how the connections are being made. So let's see that first. So when you talk about convolution networks, so basic operation in convolution neural network is convolution operation. So convolution operation is an operation on 2 functions of real value argument, where in CNN, first argument, when you apply convolution operation, first argument is always a input image, and second argument with which you perform the convolution is kernel. Now, how will you define a kernel? Kernel is actually when you want to say, for example, we talked about that Taj Mahal wala image. So Taj Mahal was a monument. So you want to identify whether it's a monument or whether it's a car. So what you do is you identify certain features. Say, for example, I found that if I identify the edges of the image, it will help me to differentiate car from the monument. So one feature is image, other feature could be number of peaks happening. Now in case of Taj Mahal, number of peaks were compared to car, there were no peak. You have a straight structure, you have a kind of horizontal structure, whereas in monument you have a kind of vertical structure. So one feature is, say for example, edges. Second feature could be sharpness of the image. Third feature could be how many peaks are there in the image. So multiple of those features are basically how many features you are identifying. Those features are considered as the kernel in case of CNN. So the number of, say for example, on an image, if you say that I am applying 6 kernels, that indicates that you want to extract 6 features actually. So what is convolution operation? Convolution operation has this formula. So if your image, if your image is like this, I have just shown the image in the form of a vector, and W is also in the form of vector. This is actually not in the form of vector. We deal with 2D images. 2D in the sense, just to explain you briefly, 2D image, third dimension is in the form of RGB. So RGB of image and kernel both are going to remain same. So how do you apply this kernel? This is your values of the kernel and this is your input image. So how you are going to do is, the formula is this, xt minus a wa. So this value will be, this is your w0 and it goes back. So this is w0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and this is your x0. This one is x0. This is x1, x2, x3, x4, and so on. So w0 will be multiplied by this, added with this, w minus 1 will be multiplied by x5. This is x0, x1, x2, x3, x4, x5, x6. So w0 will be multiplied by x5, w minus 1 will be multiplied by x5, w minus 2 will be x4 multiplied by this, and adding all these multiplication together will give you this value. This is 1.80. How you are getting this 1.80? Multiplying and adding this. Now shift this to one pace. 0.50 will come here. 0.50 will come here. So 2.10 will be multiplied by 0.05. This will also move in 1. You have to move this. That's all. You move this in this direction and you'll be able to get the convolution operation results, multiplying and addition. So this is what is happening in convolution operation. And if you remember, first layer of the CNN, first layer of CNN was having convolution operation actually. So you are convolving with kernel. Kernel is nothing but feature. What feature you want to extract? So that feature is represented in the form of kernel. So that kernel you move on the image and you get the output values which you get from the image will be treated as the feature value of that image. That is called as feature map. So when you apply this, say for example, this is your 2D kernel, 2 by 2 kernel, and this is your image. Okay, so this is your image. So when you move this kernel over this image, so this value will be multiplied by this, second value will be multiplied by second, third value will be multiplied by this, z will be multiplied by f. So first value which you will get is aw plus bx plus ey plus fz. Second value will be, you just move it to one place. So a, b, c and d. C will be multiplied by f, d will be multiplied by, sorry, not x. What is the value here? I cannot see the screen. What is happening? Yes. So this is wx, y and z. Wx, y and z. So this is w will be multiplied by g, h will be multiplied by x, k will be multiplied by y, l will be multiplied by z. So you will have this moved on this direction, then moved in this direction. So this is a convolution operation. So you can see it here also. You have this kind of filter, which is, filter is nothing but the kernel. This is what is this kernel represents. Dark rectangle on this image. So you can move this dark rectangle over this image. So when you place this value here, you will get a single value by performing this operation. You move it in one direction, apply on this, this and this, and you will get this pixel value, and so on. So when you are here, you will get this value. When you move it here, you will get this value, and so on. So this is just in 2-dimensional. If your data is in 3-dimensional, you could see it here. If your input is in 3-dimensional, this is x, this is y, and this is z direction. RGB channel is z direction. So when your image is in 3-dimension, your kernel will also be having 3rd dimension as the RGB value. So your kernel will also move in this direction. Kernel will also match with the RGB. So what you are getting here is, this is called as feature map actually. This is a feature map, this is a feature map, this is also a feature map. So this is what we talk now. After convolution, what is the next? What is the next operation being happened is pooling, max pooling. Max pooling is a operation. Generally, what you do in pooling is, generally pooling is with 2x2 size. 2x2 size means it is generally with 4 values which you consider. And this, when we talked about this convolution window, we started with this, then we moved it in one direction, then it moved it at one place. So you got 1, 2 and 3, 1, 2 and 3 values, and you moved it vertically down also by one place. So this is called as the stride of your window. How much movement you are doing at one time. You could do it movement wise, you could move it in one place, you could move it 2 places also. So when you move it one place, your dimension actually affects how you move your window. Pooling is generally happens with striding of 2. Striding of 2 in the sense, pooling is nothing but max pool. So max pool is, you consider this window, you move this window over this, say. So when you move this window over this, you will consider 1, 3, 2 and 9. Whatever value is the max will be the value of this. So when your max pool is here, so 9 is the maximum value out of these 4. So this is 9. Now you will move your max pool to this. So 2, 1, 1, 1. Max is 2. So this is 2. Now you will stride by 2 values. So here, from here, you are moving to here. Now from here, you will move to here. So 1, 3, 5, 6. Max value is 6. So this is 6. 2, 3, 1, 2. This is 3. So what is the result of this max pool? Image values were this, and max pool has reduced this to this. So what is the purpose of max pool? Max pool actually reduces the data, but it tries to maintain the relationship among the data. It does not lose the information actually. So that is called as pooling. So you could apply pooling on this with the different stride you could try out. So when you have this and your window is 3 by 3, So when you move it in the first place, you will get this movement. Highest value is 9, so this will be replaced by 9. Now stride is 1 we are talking about. Stride 1 means earlier your window was here. Next time your window will be here. So you will be finding out what is the next max value for out of these 9 values. It is 9 again, so this is 9. And then you will move it to here. And what is the maximum value here? It is 5. So this is 5. So now you move downwards and you keep on moving this window up and down, and you will get these max pool values. So this is what is happening in max pool. You could have max pooling average also. Instead of having only max, what you could do is you could add all these values, divide by f, just do the average. 9 plus 3 plus 2 plus 1 divided by 4 will give you this, and so on. So pooling layer, you could perform average pooling also. Now there is a relationship between. Now what happened here is we have convolution here. We are doing convolution here. So you have input and you have convolution here. How convol is being happened? Convol is being happened with respect to the kernel which you are applying. So actually after convolution, after every operation, image dimension actually changes. Now how image dimension changes after convolution? Before convolution, what you are doing here is convolution. If your window is 7, if your original image is 7 by 7 and you are applying a kernel of 3 by 3, so after applying kernel of 3 by 3, you will see that your image will come out to 5 by 5. Actually, how it is coming out? It is applying this formula. W2 changed image value will be W1 minus F plus 2P. We have a actually logic behind this. This P is called as the padding. Padding is done because at the corner pixel generally does not get any importance. So if you want to give importance to corner pixel, we pad this whole image with 0, 0, 0 on across all the directions. So how much padding you are doing? So that P is that number. F is what is W1 original image size minus F is a number of filters. Special extent of the filter. What is the size of filter? Currently, for example, if this is, for example, if this is your filter, for example, so size of this filter is 4 by 4. Filter is always square matrix. It is never a rectangular matrix. It is square, means 4 by 4, 5 by 5, 3 by 3, 2 by 2, and so on. So F specifies a special extent of the filter. K is total number of filters, total number of features. Kitna you want to work with, how many features. So W2 and H2 will be calculated by W1 minus F plus 2P divided by S. How much movement you are doing? Stride kitna hai uska. Okay, so you will get W2 and H2. So after you give input and you apply convolution of the images, your image size will be reduced. That reduced images will be input to max pool, which will again reduce the size. You have seen it. So image size was earlier this, you applied this max pool, image reduced to this. So it depends on how much filter size you are taking and how many, say for example, you have an original image of 227 by 227. 3 is the width. So we are not considering width because my kernel is also having the same width. So if I am applying 96 filters, 227 height and width will be reduced to W2 will be calculated based on W1. W1 was 227 and you are applying a filter of 11 cross 11. You are moving a filter of 11 cross 11 over the image which is having 227 height and 227 width. Height and length 227 and 227. So when you move this filter over this image, what will be the output of this? Output will come out to be 55 only, because 227 minus formula was this thing, W1 minus F plus 2P. We have not done any padding here. Here you can see padding, but then in the image we have not done any padding. So P is 0. So 227 minus F is 11 by 11. So F is 11 divided by 4. If I am saying that my stride is 4, it means I am moving with 4 positions ahead in X and Y, both direction. So 227 minus 11 divided by 4 will be 54 plus 1 is 55. So your image has reduced from 227 to 55 cross 55. But then this is one filter only. Likewise, you are applying 96 filters. So your dimension will be 96. Dimension in the sense each filter will be having depth of 3, but then how many filters you are applying? 96 filters you are applying. 96 filters in the sense you are extracting 96 features from the image. Now, there is an advantage of CNN. CNN is how do you see a regular feed forward neural network? You have an input and that input is connected. Say this is first layer, this is second layer and so on. So this input is connected with this neuron. All inputs are going as into this. All inputs will go as into this and all. And output of this will be into all of this and so on. So you can see a many dense connection here. Here we just show one, but here also we just show one few connections here, which looks very dense here. So all inputs are connected in contrast to what happens in case of convolution. If you see this convolution, what is happening is, say for example, this was having 16, for example, you are representing image of 2, which is having 16 bits, for example, 4 cross 4 images there, which is having 16 values. So how you are representing that 16 values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is if you are not representing this data in NN, you are representing that in CNN, for example. Abhi iska convolution neural network mein we are giving that input. So what will happen is that connections, you can see this very less number of connection happens in case of neural networks. So connectivity is very sparse in case of neural networks. So for example, you remember we did convolution. So when you are doing convolution with this size of filter, 2 by 2 filter, when you are moving 2 by 2 filter on this, so when you apply 2 by 2 filter, initially you will consider 1, 2, 5 and 6 pixels. So 1, 2, 5 and 6. 1, 2, 5 and 6, this will be giving you this value, which is this will be 3, 4, 7, 8. So this is 3, 4 and this is 7, 8. So 3, 4 and 7, 8 will give you this value, that is this value. Next 4 will be having these. So next 4 will be connected. So you can see this at the first layer of neuron, few are connected with this, few are connected with this, few will be connected with this, because this is taking care of sparse connectivity. Actually, what we want is this is a very important property of image processing, that nearby pixels gives you more information. So that is being captured in case of CNN. So that sparse connectivity is actually helping us. It is not, there is no disadvantage because of that sparse connectivity. So what it does is it helps in reducing the number of parameters. It helps to take computation faster compared to the neural network, because you have less connection. Now it is not that connectivity is being lost in this case. So it is not happening actually. So what we did here is we just saw first layer. When you go again up, you will see that connection is happening of every neuron is connected with every other neuron. So you could see this was not connected directly with this here. But then if you go up, you will see that this is connected with this is connected with this is connected with this, and so on. The connection will happen. So actually we are not losing any information because of that sparse connectivity. So now let's see, this is how does this neural network looks like? Say for example, you have an input, you have convolution layers, you have max pool, again convolution, max pool. I told you could have multiple layers of convolution layers and max pool layers, and then finally you have fully connected layers here. So this is input, and what you can see this here, we have applied 6 kernels. First kernel is this, second is this, third, fourth, fifth and sixth. We applied 6 kernels. Each kernel is of size 5 cross 5. So initial input was 32 by 32 where you have written an image. So 32 by 32 image will change to it will change to dimension will reduce to 28 by 28 because we did that formula W2 equals to W1 minus F plus 2P divided by S plus 1. So this image size will reduce to 28 by 28, 28 by 28 for all 6. This is one kernel, another kernel. Likewise, we applied 6 kernels. So total number of parameters which you are parameters learning in the sense you are learning the weights of that kernel. So how many weights you are learning? You are learning 6 times. For this, you are learning 5 weights, 5 cross 5 weights. For this also you are learning 5 cross 5 weights. For this also you are learning 5 cross 5. So total number of parameters being learned at this convolution layer is 5 cross 5 cross 6. That is 150 parameters will be learned at this layer. And what max pooling does is, you remember max pooling, we keep the stride of 2 and we just find out what is the maximum value in that window. So what is happening here is we are taking a max pool of 2 and then this size of this image will reduce to just 2. 28 divided by 2, that is 14 by 14. And in case of max pool, nothing is happening. We are not learning anything. We are just reducing the size of image so that it is easier for next layer to compute faster. Next layer, again what you are doing out of this, again you are applying 16 filters and or for all 16 filter each of size 5. So total parameters learned would be 5 cross 5 cross 6 cross 16. 6 yahin pe, because 6 filters you have already applied on each of this 6. What you did is you applied 16 again. So 6 multiplied by 16 again. This will reduce the size from 14 to 10 and then 10 to 5. And after this 5, you have all these, whatever data you got it here, all these are connected to a fully connected layer which is having 120 neurons. So all data, it's not layer, it is converted in a vector form. 120 fully connected, then goes 84 fully connected, then goes output. Say my characters were 10 only, so my output will be in one of the 10 classes. So this is these are few pre-trained networks already available where the size of input is specified and where the size of max pool, number of kernels which you are applying, everything is done for you to make use of these things. LXNet has LexNet. This is architecture of LexNet. This is architecture of LXNet where this original image size is this, and then it is convolved using 11 cross 11, then max pool is done, then this, and then this, everything is specified here. Everything is already trained for you. You can make use of this. You can give your images to this trained network and can find out what accuracy your model is giving you for that particular data, because model training takes lots of time. So these are few more which has already defined values of this. So I just build a simple basic model for you to explain you how image classification happens with CIFAR 10 dataset. So CIFAR 10 dataset contains 60,000 32 by 32 pixel images of 10 classes: aeroplane, automobile, bird, cat, deer, dog, frog, horse, ship, truck. So out of this 60,000 images, 50,000 is used for training in my code and 10,000 is for testing. So you can see these images. These are some sample images of CIFAR 10 dataset. You could see images of horse. You could see images of this. You could see images here as bird, this car, aeroplane, and so on. So you'll find images for all 10 classes. So how do you build the model? You first have to take the data from CIFAR 10 load data, which is inbuilt into the Keras library. So you import it first, Keras, import layers and models, and you import the data set from the Keras only, that is CIFAR 10. You can import it, and these are few functions which is required for implementing this. So what we did is we have imported the data first. So train data images and train label. Label in the sense why this is a supervised machine learning. So what data you are giving, you should specify the labels also, that this data is of what. And then again test images and test labels. Do that, see this. Model is made sequential in the sense convolve, max pool, then convolve, max pool, and keep on doing this, and lastly you're flattening the data, that is dense connection. So first convolution layer is having 32 kernels or 32 filters you are applying. Each kernel is of size 3 cross 3. And after doing this, your input is of 32 by 32, and you are applying on this 32 by 32, you are applying 32 filters, each of size 3 cross 3. And then you are doing max pool with 2 cross 2. And after doing this, again you are applying 64 filters, each of size 3 cross 3. Then you are doing max pool of 2 by 2. Then you are again applying 128 filters of each of size 3 by 3. And max pool 2 cross 2. And after doing this, convolve max pool, convolve max pool, convolve max pool 3 times. After finally what you are doing is you are flattening the data in the sense you are converting 2D data into 1D. You are creating a vector actually. And dense layer 128. So all data will be in 1D after this max pool, and all data will be connected to 128, all 128 neurons. Now all these 128 neurons will be connected to last dense connection, which is output. So all 128 will be connected to all 10. So when you run it, you have to make use of model.compile, and it will train the model, and you can specify the test images and can see what, when you train it, you will see this kind of output. It will, what we are doing here is we are training it for 10 epochs. 10 epochs means first iteration, second iteration, third iteration, and so on. When you train it, your model will learn, and it will give you certain accuracy. For example, it is giving you accuracy of 71.74%. So when you give some test image, so I have given some test image to predict it. I have given a cat.jpg, and it has predicted the class also as cat. It could have predicted something else also. Why? Because accuracy is not 100%. Accuracy is 70%, 71% only. So you can program it for just to see how this is working. So that's all from my side. We have some more thing, but I think I should stop now. So
Yeah,
if you
ma'am.
have any questions.
Participants, any questions from your side? Please ask. Ma'am?
Yes.
Yes. It's the time to thank Madam. So on behalf of the organizing committee, I express our sincere gratitude to Dr. Sandhya Arora for her enlightening and knowledge-rich session. Your deep insight into AI application in signal processing and image and video analytics have greatly benefited all of us. Thank you for sharing your vast experience, research expertise, and valuable perspectives. I also extend my thanks to all the participants for your enthusiastic participation and continuous engagement throughout today's session.
Madam, can you please click a GPS-based photo? I need it.
Yeah. You need the presentation viewer, ma'am.
Anything would work.
Yes, I want to take the screenshot.
Or should I take? Wait.
Okay, ma'am. Okay. You will take it. Audience, it is possible you can switch on your video. That is because Madam is taking the screenshot of the session.
How to change the layout?
Yeah, ma'am.
How to change the layout?
Which layout, ma'am?
Only one here. Layout of
all participants. Okay.
How to change layout?
Is it okay, ma'am?
In the top view option is there, ma'am. In the top,
view option is
you can change
what should
the view there.
Gallery.
You can change the view there for your We can see, ma'am, we have taken few screenshots.
Sir, please, we can do this one and share to ma'am. Ma'am, sir.
Okay.
Sandhya, ma'am, if you can be seated on the chair, we can take your inclusive photograph as well. Yes. Participants, if you can switch on the video, we can take a participants' photograph together. That will be for our record as well.
Yes.
Thank you so much. Yes, I can see many people coming
Thank
now.
you so much.
Okay. So this is the time for giving vote of thanks. It is my pleasure to introduce Dr. Ashish.
Ma'am, can we
Mulajkar.
wait for 1 minute?
Okay, okay.
Prema, ma'am, can we wait for 1 minute?
Okay, okay.
Since people are switching on the video, will once it is done, I'll ask you to start.
Okay, okay.
Okay, ma'am, you can continue.
Okay, it is my pleasure to introduce Dr. Ashish Mulajkar, who will now deliver the vote of thanks. Dr. Mulajkar is a distinguished academician and technician with specialization in VLSI design and embedded system. He holds a PhD in VLSI design from Lovely Professional University in the year 2022 and an MTech in embedded system from JNTU Hyderabad with over 16 years of rich academic experience. His expertise lies at the intersection of embedded system, VLSI, and outcome-based education. He is deeply committed to making complex engineering concepts accessible and meaningful, often aligning them with his sustainability goals and real-world application. He has published research papers in Scopus Index Journal, presented at international conferences, and holds one utility patent, one design patent, and one copyright to his credit. Along with his academic contribution, he has also handled several administrative responsibilities during his professional journey. We are indeed honored to have such a dedicated academic leader among us. Now I request Dr. Ashish Mulajkar to kindly deliver the vote of thanks. Thank you, sir.
Thank you, ma'am.
Thank you, sir.
Am I audible, ma'am?
Yeah, audible, sir.
Yeah. First of all, ma'am, on behalf of MIT.
So you're audible, but your voice is very low. Okay.
Yeah. Just a minute, sir. Sir, am I audible now?
Yes, sir.
Yeah. So, first of all, on behalf of MIT Academy of Engineering, Alandi, Pune, I would like to thank all the participants, all the distinguished session chairs, all the distinguished session coordinators, as well as the chief guest for gracing this occasion for the last 5 days. I would also like to thank the AMIEE Association, the CMAOI Association, the RAHCS Association for being associated with this particular FDP. In the last 5 days, all the participants, we have discussed about the AI or the applications of AI in the respective fields of electronics and communications like VLSI, embedded systems, IoT, signal and image processing, wireless communications, healthcare electronics, smart agriculture and EV, as well as EV in robotics and automation. So I think it was a wonderful experience for me as well as for all the participants. I would like to thank all the speakers for their dedication towards their respective domains. Last but not the least, I would also like to thank the HOD of our department, Dr. Deepti Y. Sakre ma'am, as well as Director of our institute, Dr. Mahesh Gowda sir, for encouraging us to arrange such type of programs. And last but not the least, I would like to thank Dr. Amir Junaid sir for his continuous guidance for this organizing of this particular FDP and workshop. Thank you very much. Over to you, sir.
Thank you very much, all participants, Prema ma'am, Ashish Mulajkar sir, and Sandhya ma'am for the extremely enriching sessions. Yesterday also we had two very good sessions. All the sessions were quite good, in fact, from day one. We are ending now this program. All participants can download the certificate of the participation from our website. It will be available maybe from Monday. We'll process the attendance and all, and then it can be downloaded from our website. I'll also share the link in the WhatsApp group from where you can download the certificate. And all the session coordinators, all the resource persons, the speakers will also receive the certificate on the respective mail. Thank you once again, everyone. Dr. Ashish Mulachkar sir, has played a very instrumental role in bringing this FDP. We were discussing for 2-3 months to make this success, and his effort has really turned out to be very useful for this FDP. Once again, I'd like to convey a message on behalf of the AMI Association that all the speakers and all the session coordinators, the academic ambassadors were all from the AMI Association. They are members of the association. And few of the speakers were from the MIT College. In association of this MIT College, we have conducted this FDP. Sandhya ma'am, thank you very much. Your session was very good. Yeah, today I was there throughout your session. It was very enriching, and hopefully we'll collaborate in future also for more such FDPs and conferences. Tomorrow there is one award ceremony conducted by AMI Association. It is for the best paper awards that will be given to the presenters in the international conference that we held recently. So I'll share the invitation in the WhatsApp group. All the participants, please come tomorrow at 2 p.m. To encourage the winners of the presenters in the international conference that was held a few months back. Thank you very much. Have a very nice day.
Thank you so much.